Hello. So today we start studying the while statement, and we use the while statement to perform iterative tasks, meaning tasks that need to be repeated. So, in the simplest sense, I can look at this very simple algorithm that describes how to do groceries in these two lines. So while there are more items on my shopping list, uh, I purchase the next item and cross it off my list. So it's a simple algorithm that describes how to do groceries, and you keep doing that until your shopping list, until everything off your shopping list is crossed off. So basically, there's a condition that you check for. And as long as that condition is true, you keep performing a certain task. That condition becomes false, and you stop. Here's a very simple example of how you can use the while statement, also called a while loop. How you can use a while statement to find the smallest power of 3 that is larger than 100. So this is an outtake of the code for that. So you initialize an integer variable called product to 3, and that is followed by 3 lines of code. The while statement right here, which checks for this condition. As long as this condition remains true, the code inside the while block is executed. After it's executed, control does not pass on to the line of code after the while block. Instead, we jump back to the while statement and we check this condition again. If the condition is still true, you jump back into this block of code, execute it, and repeat. And repeat until whatever condition is put into the parenthesis over here becomes false. This is the flow chart for this very simple program. So basically start over here. Check if the value of product is less than or equal to 100. If it is less, you perform this step. You multiply the value in product by 3 and make that the new value of product. And then you jump back and check again if the value of product is still less than or equal to 100. If it is, repeat. Once the value of product exceeds 100, this condition becomes false and you exit the loop, the while loop. In this particular example, we start off with a value of 3 in product. The next time you encounter the while loop, the value will be 9, which means the condition will still be true. You go through the block of code inside the while loop. At the end of that, 3 multiplied by 9 will be 27, which still keeps the condition true. You go through the while loops block of code again. At the end of that, the value of product will be 81, which means the while condition will still be true. You go through the block of code one last time, after which the value of product will be 243, which will make the while condition false and which will let you exit the while loop. Let's look at a slightly more substantial example. So let's say we want to compute the average, the class average of a quiz in a class of exactly 10 students. And let's say the grades for that quiz are allowed to be in the range of 0 to 100. Can't be negative, of course, and cannot be larger than 100. And yes, they'll be integers, so no fractional numbers. You can compute the class average by adding up all the grades of all the students and dividing by the number of students. In this case, 10. This will be an example of using the while loop in a way that's called counter-controlled iteration, meaning you're counting the number of times you're going through the while loop. Once that is completed, you exit the while loop. In this case, the value of the number of times we'll go through it is 10. So first, let's take a look at the pseudocode for this. One more thing, counter-controlled iteration is also called definite iteration. Definite iteration because before you enter the while loop for the first time, you already know how many times you're going to go through it. Okay, so this is the pseudocode for this very simple example. We'll have a variable called total that we set to 0. We have another variable called grade counter, or we'll have a grade counter that we initialized to 1. And then we have our while loop, which will run until the grade counter is less than or equal to 10. And as long as that is true, we will input a new grade for a new student, add that grade into the total, and add 1 to the grade counter. Another word for that is increment, add 1. So after we do this for 10 times, we exit the while loop and we assign to the average the value of the total divided by 10. Finally, we print out this average that we have computed. This is the code for that, and we'll look at it also in the hands-on section. The new parts, like always, are highlighted in yellow. And the counter variable, we're calling that counter. And you see something new here. Now, if you're just counting stuff, you want to make a variable like that an integer, fine. But in this case, we know that the counter will never be able to have a negative value, or never should, even by accident, ever have a negative value. And for that reason, we make this not just an integer, we make the counter variable an unsigned integer, meaning it can only have values, integer values, 0 and positive, but not negative values. Other than that, we define an integer variable grade, total, and average. Total is initialized to 0, counter is initialized to 1, and here we have the while statement with the condition that we're going to check every time. Counter is less than or equal to 10, just like it said in the pseudocode. So starting at 1, as long as the value of counter is less than or equal to 10, we'll keep doing what's inside here. Print out a message saying enter grade, space, followed by a scanf function that receives an integer in decimal form and stores it in variable grade. The value of grade is added to total and stored into total again. So basically we are updating the value of total. We're adding the grade value into the total, which again was initialized initially to 0. And finally, we are updating the value of counter, right? We have to count how many times we go through the while loop. Finally, we divide the value of total by 10 and put the result into the integer variable average. And then we print out the value of average in this message. Class average is whatever the value of average is. Here's an example of the sample output of a test run. So over here, student grades, the 10 students grade that we're entering are 98, 76, 71, 87, 83, 90, 57, 79, 82, 94, which comes to a class average of 81. Now there are some details to this that we'll get to. One thing you have to remember is that whenever you declare a new and define a new variable, you have to initialize it, because if you just create a variable, do not give it an initial value before using it, you have no idea what's in there. And what's in there is what we call a garbage value. It's unpredictable. It will not be initialized to, say, 0, like some other languages will do, not in C. Typically, counter variables like the integer counter that we've been using are initialized to 0 or 1. Whenever you're adding up, accumulating values like we do for total, variables like that are also initialized to 0. Another thing that you may have noticed is that average was defined as an integer. Now, the total in the example that I showed you, actually the total comes out to 817. So the sum of grades of all 10 students is 817. When you divide that by 10, the actual average is 81.7. But what we see over there is 81, and that is because we are dividing one integer number, total, by another integer number, 10. And the result will also be an integer. And the fractional part over here is simply not stored, cannot be stored in average, because again, average is just an integer. So we need to fix that, and we'll do that now. So let's make another approach at this problem. This time, let's try to come up with a more generalized solution to the problem of computing the average of grades of students. And this time, let's say that we want to compute the average of not just 10, but an arbitrary number, meaning any number of grades each time the program is run, not only 10. And for that, what we do is we have to somehow signal to the program that when we have entered all the grades, we need to somehow signal it that this is the end, there's no more data. And we do that using something called a Sentinel value, or a signal value, or a dummy value, or a flag value. Now, put simply, we input a number that makes no sense, that is not a valid data value. Now, in this particular example, we are working with grades, and we know that grades cannot be negative. So, for example, but we are entering integers. Integers can be negative numbers. So if we were to enter, for example, the value -1, that does not make any sense as a grade, but we can then make use of that as a signal to the program. It's a dummy value, an invalid value, or also called a Sentinel value, signaling to the program that this is the end of the data. There's nothing else. There are no more student grades. And that way, the while loop can evaluate a condition that will then turn out to be false, which will allow us to break out of the while loop. This type of iteration, this type of looping is called indefinite iteration because we do not know beforehand how many times the while loop is going to execute. It will depend on data depend on data based on input from the user in this case. So we are going to stick with -1 as our Sentinel value. So as an example, let's say the program, when it receives the following values, 95 followed by 96, 75, 74, and 89, and then in the end it receives -1, that -1 will basically tell that we're finished entering data. There's nothing else to enter. So let's attempt a slightly more stepwise, top-down approach to starting with basically first a problem statement of what the program should accomplish. Determine the class average for the quiz. That can be further broken down into or refined into slightly finer steps. So first of all, initialize variables. We want to do that first. Then receive input, sum up those inputs, and count the number of grades that we have received. Finally, calculate and print the average. It's still not very descriptive, not enough to start writing code perhaps. So initialize variables was the first step over there. In that specifically, we would like to initialize the total to 0 and the counter variable also to 0. Then that pseudocode says get input, compute the sum of those inputs, and count the quiz grades. That can be expanded into something like this. Input the first grade, and as long as the input received from the user is not the Sentinel, keep doing the following. And this is now inside the while loop. Add this received grade into the total, add 1 to the counter, and ask for the next grade. And then check if that grade is a valid value or the Sentinel value. Notice that this is still just pseudocode, which means you do not see any parentheses or any of that. This is not actual code, just a description of what the code will do. And ideally, it should be detailed enough that anyone can look at the pseudocode and come up with a program with their own versions of the program perhaps, but that nevertheless accomplish the exact same thing. One thing we have to take care of over here is that if one situation that you have to handle is if the number of grades entered is 0, because if that happens to be the case and you divide whatever's in total by 0, you will get an error. Actually, your program will crash. So you have to check for that situation to make sure your program does not crash. And in the last step, we do that basically in the last step. We have an if, an else block. If the counter is not equal to 0, then you compute the average by dividing total by the value in counter and print out the average. Otherwise, you just print out this message over here. No grades were entered. Okay, this is what those different pieces of pseudocode that we just came up with, what they look like put together. So this is the initialization part. This is receiving input, computing sum, and checking if the value is not the sentinel value, and finally checking if the number of grades entered or the value of the counter is not 0. And if it is not 0, compute the average and print it out. Otherwise, print out a message saying that no grades were entered. So this is the pseudocode that we just developed, put together. Now let's come to the actual source code for that. There's some differences from the previous version. Again, they're highlighted in yellow. So first of all, average is now declared a floating point number. Counter in the previous version was initialized to 1. This time we're going to initialize it to 0, and you'll see why that is necessary, because we want to make sure that the number of grades entered are not 0. Okay, so we start counting at 0. Another thing that happens is the first input, first grade, is read outside of any while loop. Okay, so print out the same message, enter grade or -1 to end, and we have a scanf function following that. And after that, we put the while loop and we check if the received value of the grade is -1 or not. If it's not -1, means all is well. The value of grade can be added to total and the counter can be incremented. And then inside the while loop, right? This is inside the while loop. We again ask for the next grade, use scanf to read it in, and then we jump back to the while statement and check the condition, make sure that this value of grade received over here is not -1. This can happen any number of times, and after a couple of inputs, hopefully, when finally at some point you receive the sentinel value over here, you'll jump out of the if loop, the while loop, jump to this if statement, and you check what the value of the counter is. If it's not 0, you can divide the total by the value of the counter, put it in average, and print it out to screen. Otherwise, you print out this message, no grades were entered. Another new thing that's happening over here is this. What is this doing? Well, this is basically converting the value in total. Remember, total is an integer. It's converting the value of total on the fly from an integer, to a floating point number, and then dividing it by counter. This is called casting, explicit casting. Explicit because you yourself are specifying to what data type a value should be converted. In this case, the value, the data type of total is int, and that is being converted by you on your say-so to a floating point number. Now, remember, total, the value of total, the variable total still remains an integer. After you have declared a variable, you cannot change its data type. I said that before. But here, to do this calculation on this whole line, temporary, so just on the fly, we convert the value into a floating point number, then perform the division. Now, because one of the two numbers is a floating point number, the C compiler will convert counter into floating point value as well. And the result of dividing a floating point number by another floating point number is yet another floating point number, and that's okay because we are ready to save that into average, which we declared a floating point number. Okay, if you do a sample run of this, and let's say you enter 75, 94, 97, 88, 70, 64, 83, 89, and -1 as inputs, the average you'll see is 82.5. Oh, one other thing. When you're printing out the value of average, look at the placeholder over here. We are adjusting, controlling the number of digits displayed after the decimal point to 2 digits. That's why this looks so neat. Otherwise, I think last time we saw that the default on some systems is 6 digits. And here's another run. So this is a more normal example of a run of this program. The second example over here, the very first grade that we enter is -1. In that case, you'll see this message printed out. No grades were entered. So I already talked about that, the casting, the converting of on the fly of values from one data type to another. That's what that looked like. You basically put the data type that you want to convert to in parentheses in front of the variable whose value you want to convert into, in this case, type floating point number. And because you are specifying, you're actually controlling which data type to convert to, this is called explicit conversion. There's another type of conversion happening over here when the division happens. Remember, counter is an integer, so but your C compiler will only perform operations on the same data type, so it'll convert automatically for you without you saying so. It'll convert counter into a floating point number before performing that division. That conversion happening over here is an implicit conversion.